Hello, this is group Henry and Michael. So, Michael is a producer, he makes his own music, and he is also an expert on music theory. Henry is a expert on EDM music, which actually stands for electronic dance music. So, within the music industry, people are starting to look for creative ways to generate music. So, we want to be a part of this. And we want to generate our own artificial intelligence music. So, let's take a look. And the reason we chose the genre of EDM is because EDM songs are the simplest form, and so they're the easiest to process within our model. So what our problem is, so we have a sample of existing EDM songs, and then so we want to input this into our model so that the model can create original and new EDM songs. And so the model is actually a type of sequence model where the input size and the output size are the same. The source of our data are EDM MIDI files from EDM Synth and EDM Hex Loops EDM MIDI Ultimate 1000. So in total, there are 275 MIDI files. You can see these are some examples of the EDM MIDI files.
So for each file, we'll first read them and we'll only use the file with 4 bars and we'll convert the tempo of each file to 120 BPM and then we get the normalized EDM synth data with 8 seconds each and then we'll convert the key to C major but the function we use have some error rate so some of them will be converted to F major or G major. After that, we'll get our C major normalized EDM synth files with all 8 seconds and C major. After we get the C major normalized EDM synths, we'll use a function called getPianoRoll to get a matrix of that sample. And the first dimension of that matrix will be the time frames. The time frames we use parameter frame per second equal to 16. So we'll have 16 times 8, in total 128 frames. And the second dimension indicates the MIDI note number. We pre-processing our data and we find out the MIDI note number range is 63. So this will be a 63 dimension vector. And for each element, 1 is for note on, 0 is for note off. If during certain time, no notes are on, we set the note 64 to be 1.
So in summary, out of the 275 original samples, we will use 194 samples, which were converted into a piano roll with dimensions 128 by 64. And then the output will also be a piano roll that will also have dimension 128 by 64. The model we will use for music generation is a LSTM, a certain type of RNN. The main difference for the LSTM is for each prediction. Unlike the normal LNN, which only depends on the previous element, the LSTM has a memory cell that carries information of the several previous notes and achieves this using gates that determine the memory cell to forget or not. This is important for music generation because songs usually have a strong song structure. So in music generation, the next note will depend on all the previous notes and not just the one previous note before it. So for our model, we use a PyTorch LSTM, and the loss function we will use is cross entropy loss. We will use stochastic gradient descent to train the model, and for the optimizer, we will use Atom.
So after training our model, we'll do the sampling. Our sampling is kind of difficult because unlike the RNN model we use for our homework, when we just generate one character at the same time, we need to generate multiple nodes. So our solution is that we sample 4 times for each time frame and will not double count the same notes we generate. And the second problem is that there are too many random notes generated in one piece. And our solution is that we only use notes that appear more than 10 frames in the 128 frames. The third and last problem is that the probability for empty node is too high. To solve this problem, we only consider the time frames have no nodes when two of the four samples we generated are empty nodes.
Our results were not that optimal. One of the major reasons was because some nodes meant to be long nodes were actually turned out to be close nodes that were discontinuous. However, there is evidence of a song structure, as you can see from the examples. For example, the second one in the middle, the top note repeats, and then the other samples, they all generally have 5 to 7 notes per song, which is typical for EDM songs.
We have several approaches to further improve our model. The first one is about our dataset. Our dataset is not too big, only 194. It's a very small sample, and we definitely need to find more data. And our data is too diverse. Maybe diversity is good for classification, but for generation, we need data with similar features. So maybe we can do classification first and then train for each class. And for our model, we want to add normalization and regularization to prevent model overfitting, and we will use batch gradient descent, which works better for music data. At last, for our sampling, we want to group close nodes together, and we'll discard the weird nodes to make our sampled MIDI file sound better. So this is our model. After doing this project, we realized that doing AI music is not that simple.
Thank you for watching our project.